My name is Gabrielle Thomas and I am a physicist. I work as an innovation ambassador for a photonics and quantum technology company called M². The company is based in Scotland in the UK, but I'm responsible, or have been responsible, for the expansion of the company here in Germany.
Was macht ihr bei M²?
So M² is a developer of photonics and quantum technologies, and we aim to use the power of light to solve some of society's greatest problems, like climate change and advanced healthcare. We've developed some of the most cutting-edge enabling tools for applications like quantum technologies and bioimaging of biological samples. And we are working really at the forefront of bringing these amazing scientific principles from the lab and into the real world.
Was macht ein Innovation Ambassador?
Ein Innovation Ambassador ist jemand, der oder die eine allgemeine Begeisterung von Wissenschaft, Innovation und Technologien hat. Mein Arbeitsalltag ist sehr vielfältig. Manchmal nehme ich an einer Konferenz teil. Ich halte Vorträge für Wissenschaftler und Wissenschaftlerinnen auf der ganzen Welt. Manchmal arbeite ich an neuen Ideen für neue Produkte und ich schreibe Förderanträge, um deren Entwicklung zu unterstützen.
Was hat dich motiviert, Physik zu studieren und dich mit Quantentechnologien zu befassen?
Als ich ein Kind war, hatte ich ganz viele Fragen. Und meine Mutter hat sich geärgert, weil ich so viele Fragen hatte. Zum Beispiel, wie funktioniert die Welt? Warum ist das so? Die Physik hat die meisten Antworten auf meine Frage. Ich war immer offen dafür, neue Sachen auszuprobieren und neue Herausforderungen zu finden. In meinem jetzigen Job bringe ich die Wissenschaft und die Wirtschaft zusammen.
Kannst du uns erklären, was man unter Quantum Sensing versteht?
Sensing involves the measurement of a physical quantity, for example, how fast something's accelerating or magnetic fields. Now, quantum sensing uses the fundamental properties of nature to measure these physical quantities better. And the idea is that if you're using quantum mechanics or quantum principles, we're able to do this with an accuracy and precision that is much, much greater than what we could normally do.
Wie genau funktioniert so ein Quantengravitometer?
The quantum gravimeter is able to measure very small changes in acceleration due to gravity. Now, how it works is that we use a laser to create a cloud of very, very cold atoms. They get cooled down to near absolute zero. When they're this cold, that's when these quantum effects start to come out, like quantum superposition and things like that. We take our cold atom cloud and then we allow the atoms to all interact with one another. And this creates a very special pattern. And we can analyze this pattern to determine how strong gravity is in that particular point.
Und wie können diese Quantensensoren eingesetzt werden?
So by knowing how strong gravity is in one place, we are able to detect things without actually having to go and dig it up. For example, you can detect underground pipelines or underground electrical cables. It can be used to detect underground burial chambers, or it can be used to detect mineral deposits under the ground. And it can also be used to detect volcanic activity. And I often think about a situation that happened. So I live in Berlin, and a few years ago, there was some building works being done on a bridge near where I live. They didn't have a very accurate plan of how the cables and the tunnels were underground. So the workers unfortunately drilled into one of the high voltage cables. Not only the main cable, but also the backup cable. And so at that time, I was often thinking they needed our quantum gravimeter.
Gabrielle, du hast berichtet, dass ihr bei M² auch Anwendungsbereiche wie Klimawandel habt. Hast du da ein Beispiel für uns?
In climate change, I have a great example of how we're having an impact. One of our lasers was used to better understand a device that has gone up onto a satellite into space. And this satellite is looking down at the world and trying to not only understand, but also to get an idea of how many polluting gases are in our atmosphere. And so this satellite was called the Sentinel-5P satellite and has gone on to generate some of mankind's best data on climate change ever. So why is this relevant to society? Why is this relevant to us? The better we understand climate change, the easier it is and the more prepared we are to be able to make decisions about what we need to stop doing, what we need to start doing to secure our future. You know, we as young people, the world, this is our future. The more information we have, the better we can prepare ourselves.
Was würdest du persönlich mit einem perfekt funktionierenden Quantensensor messen wollen?
The ideal thing that I would like to do with a perfect quantum sensor is to take measurements of the brain or the brain's function. There's some really exciting research being done in this area right now. I find it completely cool. The brain still has many, many secrets. We don't understand very well disorders and diseases of the brain. By using an incredible quantum sensor that is able to help us unravel some of these secrets, I think would have an enormous impact on society.
Warum sollten wir uns mit dem Thema Quantentechnologien auseinandersetzen?
You have the possibility and the opportunity to engage in a very rapidly developing, exciting field. And this field has the potential to revolutionize our lives. From my perspective, that's super exciting to be part of the revolution.